Hey, welcome back from spring break algebra. Yay, we get to do math again. Okay, um, so we're gonna jump right in. We're building on what we did before, except it's enough of a shift that we don't need to really review what we did before. So we're hitting the floor running and learning to use square roots to, just like we were doing before, solving quadratic equations. Before, the only way that you knew officially to solve a quadratic equation is by using the zero-sum property. What you did was you would factor it and you would say something like x plus 3 times x minus 2 equals 0. That had to be a 0. And then you would say, well, that means that this has to be 0 or this has to be 0. So x is equal to negative 3 or x is equal to 2. Okay, that would be the only way that you, until today, officially knew how to solve quadratic equations. You would factor them, that had to equal 0, and you would use the zero product property. Well, now we're going to learn another way. If you think about our warm-up again, there were some basic kind of rules that we had, or not necessarily rules, but just general knowledge of the number of solutions that you would have. By the way, you're also heard this referred to as taking square roots. So if we're solving the problem x squared equals d by taking square roots, well, if we look at d and we think about what d is, well, if d is greater than 0, so let's say d is 25 or 140 or 5,000,000.5, well, then x squared equals d has two solutions. It has the solution of positive the square root of d and what? Negative the square root of d, right. So we would say positive and negative the square root of d. But Miss Decker, don't we know that it has to be both positive and negative if we're saying the square root of d? Yes and no. When we have this radical sign, when we're talking about finding the square root and we write it with a radical sign, we're only talking about the principal root, which is only the positive. So that's why we specified positive and negative square root of d. Okay, if d, though, equals 0, then x squared equals d. Well, let's see, x squared equals 0. How many solutions do we have? We only have one solution. What would that be? Well, x then would have to equal 0. Because that's the only number we can multiply by itself to get 0, right? So if d is 0, the square root of d will also be 0. If d is less than 0, then x squared equals d. Well, what happened? If you had x squared equals negative 5, what happened to your solutions? Right, you had 0 solutions. There is no real solution to that. And if you really want to be a stickler, you could say that. There's no real solution. There are imaginary numbers, but we're not there yet. In fact, okay. So if d is less than 0, if it's a negative number, then there is no real solution to that. So let's move on. We're going to start nice and easy. If we have these equations, a, b, and c, we're going to take them one at a time. So first we're going to look at equation a. Z squared minus 5 equals 4. So step 1, write the original equation. Woohoo, I did that for you. So step 2, we're going to add something to each side. We want to isolate what is being squared. Okay? We want to have nothing on this side except for a variable or as close as we can to just a variable being squared. And you'll see examples where it's not that. So what are we going to add to each side to isolate that? We're going to add 5 to each side. We'll end up with z squared equals 9. And now we're going to take the square roots of each side. Square root of z squared is going to be z, and the square root of 9, well, we're going to talk about the plus or minus the square root of 9. I know some of you already see the solution, but just bear with me. So z equals plus or minus the square root of 9. And then we're going to simplify, which means z equals plus or minus 3, and identify the solutions. We have two solutions. We have z equals 3 or z equals negative 3. But you can just write it as z equals plus or minus 3. That's good enough. In fact, this is probably the preferable way to write it. Okay. R squared plus 7 equals 4. Write the original equation. Already done. subtract something from each side. We're going to subtract 7 from each side. So we'll end up with r squared equals -3. And then identify the solutions. Right, this is a negative number. And right now we don't have any real solutions. There's no real, there's no square root of a real negative number. You'd have to deal with the imaginary numbers again. So there's no real solution to this. Okay, on to C. Write the original equation. Done. Divide each side by 25. We'll end up with k squared equals 9 over 25. Take the square roots of each side. We'll end up with k equals plus or minus the square root of 9 over 25. Simplify and identify the solutions. So the square root of 9 is 3. The square root of 25 is 5. If this jump right here freaked you out, you might need to practice on IXL a little bit. Because all I did was I said, well, the square root of 9/25 is the same as the square root of 9 over the square root of 25. Square root of 9 is 3. Square root of 25 is 5. And so we have two solutions. K is plus or minus 3/5 is good enough. Okay, go ahead and solve the equation. Pause if you haven't already. And then play when you're ready to see the solution. Okay, solution to number 1. Well, first I had to divide both sides by 3, and then I had to just simplify for the square roots. X equals plus or minus 6. This one, we have t squared equals 0, t equals 0. All I had to do was subtract 17 from both sides. I end up with that being a 0, so t equals 0. Simple enough. Let's move forward. Okay. We're going to continue solving quadratic equations. They're going to be a little more complicated now. So we have 5 times x plus 1 squared equals 30. I'm throwing a couple things at you at once, but you guys are smart. I know you can handle it. So step 1, write the original equation. You don't have to on your notes. I do because I messed up on the notes. So there's my original equation. I'm going to divide each side by 5. So I've got x plus 1 squared equals 6. Now, what am I going to do next? Because I still have stuff here, and I said get as close as you can to just a variable squared. I'm going to take a time out here. I'm going on a tangent. Because what some of you did on the quiz was you went ahead and you multiplied this out. So you said, okay, x squared plus 2 plus x plus 1 equals 6. Again, do not write this down. I'm taking a tangent because I'm showing you why this is what we do not do. So if we did this, then we'd try to solve and we'd end up with x squared equals negative 2x plus 5, and then we would try to find the square root. X equals the square root of that stuff, and I don't know how to do that, which is why we're not going to do that. No sir, no way. Instead, we're going to take the square roots the way they are now. As long as we've gotten rid of everything that we can, and all we are dealing with is a base and an exponent, that's as far as we can go. So we're going to take the square roots of each side. Well, the square root of x plus 1 squared is going to be x plus 1. Square root of 6 is going to be plus or minus the square root of 6. And now we're going to subtract 1 from each side. So x equals x equals negative 1 plus or minus the square root of 6. Okay, so that was the first little bit of a left turn that I threw you, is that we had that base which was not just a root, or not just a variable. The next left turn that I'm throwing you is this square root of 6, because that's not a perfect square, right? So over here on the right, I'm going to remember how to estimate, in case you can't use a calculator. Quick reminder on how you estimate these square roots. Well, the square root of 6 is going to be greater than what and less than what. So think about what perfect squares are on both sides. Right, we have 4 and 9. So that means that the square root of 6 is greater than 2, but less than 3, and less than 3. So now we can say that square root of 6 falls somewhere between 2 and 3. Well, so that's 2 point something. 2 point what? What are we going to do? Well, how far away is 6 from 4, and how far away is 6 from 9? It's 2 away from 4 and 3 away from 9. So it means it's going to be near the middle. It's about as far away from both, but maybe a little closer to the square root of 4. So I'm going to estimate the square root of, I'm going to estimate 2.4 because it's about in the middle, a little closer to 2 than 3. But luckily you guys get to use a calculator, so you're going to find out that the square root of 6 is actually approximately 2.45. You can round off. So now that I know that, what do I have to do back here? Well, I have to break off into my two alternate universes. Because remember, this is plus or minus the square root of 6. So in one of my universes, I need to add that 2.45. Remember, the square root of 6 is 2.45 about. So x is approximately equal to -1 plus 2.45, or x is equal to -1 minus 2.45, because all we're doing is that plus or minus square root of 6. Okay, and now we keep going. Oh, but here's what I realized later. These shouldn't be equal signs. These should be the wavy equal signs because we're approximating at this point in time. Okay, so that means that x is approximately 1.45 and x is approximately -3.45. Yes, I changed to using and. Different teachers have different preferences. It doesn't really matter. The fact of the matter is that if I test both of these out, they'll both work. So I could say that it's an and, or you can say it's an or. It doesn't really matter. But I have these two solutions. Okay, so here's your checkpoint. Go ahead and pause. Do it on your own. I'm going to go check Facebook. All right, so let's see how you did. Well, what I had to do was I had to divide both sides by 3, so I ended up with m minus 4 squared equals 4. And then I had to take the square root of both sides. M minus 4 equals plus or minus 2. And so if I add 4 to both sides, I'll end up with m equals 4 plus or minus 2. Well, now I have to break off into my two universes. So m equals 6 and m equals 2. Because if I add these, 4 plus 2 is going to be 6. 4 minus 2 is going to be, 2. Okay? All right. There's my solution to the next one. Okay, one last thing I want to do before I end this rather long video is I want to set you up on the homework. Most of the problems we just have in the notes, so no big deal. But this problem you might run into and feel a little lost at how to do it. But what we're doing is we're being given an area, which in this case is 38 pi inches squared, and we're being asked to find the radius of that circle if this is the area. And you got to think about, well, what's the formula for area of a circle? That's pi r squared. So don't get confused and think that they're giving you a formula here. No, they're giving you the actual area, and what you're going to do is this formula to solve that. So what do you have to do? Well, you have an a and you have an a, so you're going to plug this in for your a, and you're going to say 38 pi, ignore the inches squared because that's just going to mess you up, equals pi r squared. So the area that we're given equals the formula for area of a circle. And then we're just going to solve. Well, we're going to divide both sides by pi to end up with just 38 equals r squared. And then we're going to say the radius then must be plus or minus the square root of 38. And then we can pull out our calculator, and we'll find that that means that radius is approximately plus or minus the 6.16. And then we have to think about it. Can we have a negative radius? Of course not. So the radius is equal to 6.16, approximately 6.16 inches. Okay, see you guys in class.